Hi, this is Mrs. Swigart, and we're looking at lesson 2.4, equations with variables on both sides. Now, the students will be able to solve equations with variables on both sides and solve equations containing grouping symbols like parentheses. So let's begin. Here's our first problem. We want our x's on the same side and our constants on the same side. Remember, boys and girls, a constant is a number without a variable. And that is a term I'm going to use a lot this year, so remember it. Now, in this case, you need to get the variables on one side. It does not matter which variable you move, just try to make the one that you move keep your variable positive. So in this case, we're going to move the 3x. So we're going to move it to the other side. Remember Ms. Swigart's rule, take it to the other side and do the opposite. So it's positive, we're going to make it negative 3x. And we're going to come out with a positive x, or a positive 1x. Do I have to write the 1 down? No, we're in algebra. We don't have to write everything down. But, okay, next, I need to move my negative 1 because we want x by itself. So we're going to take our negative 1 to the other side, do the opposite. So we're going to add 3. And we end up with 3x. Then we're going to put 3 back into our equation and check our work. Now, if you want to make 100 on this section, guys, check your work on every problem and you will make 100 on that first test, or the second test. Excuse me for that. But anyway, check your work. Next problem. Okay, once again, we've got the same thing, except for this time, we're going to move the negative 3y. Why? Because when I move it, we end up getting an 11y, and it keeps our y positive, which is a good thing. Now we want y by itself, so we're going to move the negative 9 to the other side and make it positive. We're going to add and get 11. And then we want y by itself, and we're going to do the opposite of multiply, which is divide. 11 divided by 11 is 1. Now we're going to check our problem by putting the number back in, and it is correct. Okay, once again, do we have to have variables on both sides every single problem? No, sometimes we have the same variable on the same side. So in this case, we're going to put the 7 and the 3 together and get 4x. And now we want x by itself, so we're going to take the 4 over to the other side and do the opposite, which is divide. And we end up with 1. And now we put it into our problem and check it. I do want you checking them, especially the first day, because it's a good habit to get into, and I'd love to see it on the test. Okay, next question. This is where I was talking about the grouping symbols. Here we're going to distribute negative 7 into x minus 3. So, our first step would be negative 7 times x gives me negative 7x, and negative 7 times negative 3, remember that negative is not just a subtraction sign, it's the sign of the number. So a negative times a negative gives me a positive 21. Now we need to move our constant. So we're going to take the 21 and move it to the other side. It's going to be a negative. We have a negative negative, so we're going to put them together and get 28, and our negative 7 just comes down. Now we want that x by itself one more time. So the opposite of multiplication is division. So we're dividing a negative 7 into a negative 28. It goes 4 times. And our last step, you got it. Check your work. So you put in 4 minus 3, you get 1. 1 times negative 7 is negative 7. It's a true statement. We got it right. Yay! Okay, now you can also have these with fractions. But guys, I'm going to show you a little trick, and it's going to be a handy little trick. It's how to get rid of fractions if you've got a lot of fractions like this problem. Now, there's a little bitty rule in algebra, and you know the rule. The rule basically states if you can find, if you do something to one side, you can do it to the other side. Well, that's what we're fixing to do. So we're going to take each one of these fractions and multiply it by the common denominator. Now, the common denominator, if you look at that row of numbers, is 8. So let's multiply everything by 8. Now, if we do that, this 8 will cancel off this one and leave me just 3. This one will cancel out and leave 2 times 1. This one will cancel out and leave me 4. And this one will go and leave me 2. So let's see what that finally gives us. So remember, this is a 1. 1 times 3 is 3. 2 times 1 is 2. 4 times 1 is 4. And then 2 times 3 is 6. Does that make sense? Now we're going to do several of these, not in our video, but in class tomorrow. So be looking for that, because this is a lesson I want you to learn how to do. Because, hey, I don't know about you, if I don't have to use fractions, I sure like it better. Okay, now we're going to put our x's on the same side. So we're going to move the 2x, and remember I told you if you can move it to make it positive, that's the way to go. That's why I chose to move it to the right. Okay? We put those together and get 6x and bring our negative 6 down and our 3 down. Now we're going to move our constants because we want x by itself. So negative 6 becomes positive 6. And then put those together, we get 9. Bring my 6x down. I want x by itself still, so we got to get rid of that 6. So the opposite of multiplication is division. So your answer is going to either be 2/3 if you just simply reduce, or 1.5. Now I'm going to tell you, in this class, most of the time if the fraction does not go into it evenly, they leave it as a mixed fraction. And they don't change it to 1 1/2. They usually leave it the improper fraction. If there's a day where you're supposed to take it to 1 1/2, trust me, I will tell you that. But on the EOI, they leave it most of the times 3/2. So I'd like you to start getting in the habit of leaving it at 3/2 as well. Now when you move into Algebra 2, they may change it to 1.5. But just a heads up, okay? Check your work, and it is correct. Now, we have a special case, and I'm sorry that the box is getting a little bit cut off. There are 2 special cases with variables on both sides, and these things happen occasionally, and they probably will happen a little bit on your homework and your classwork. Okay, first step, draw our line in, move our 2x. Now, when we move our 2x, it becomes negative 2x. Hey, wait, when I do that, I get 0x. I end up having a statement that looks like this because the 0x, 0 times x is nothing. I can take it out. So I end up with 5 equals negative 3. Is that a true statement? Absolutely not. It's never true. So this tells you that this answer has no solution. Special case 2. Well, the first thing we're going to do is distribute. So 3 times x is 3x. And 3 times 1 is 3. Now we're going to put our 3 and our 5 together and get 2, because you have a positive and negative, you subtract and take the sign of the larger. Now we've got to move our x's to the same side. So I'm going to move my 3x over. Now wait a second. This time it fell out again, just like the previous one, but what's the difference? I have negative 2 equals negative 2. Well, guess what? When they equal each other, and it's a true statement, there are an infinite number of solutions. Basically, the lines are the same, usually. It's also called the identity property, when you get something equals the same thing. Okay? Those are our 2 special cases. Look for them tomorrow. There'll be at least a couple of problems with these 2 special cases. I want you to get them down because they might be on the EOI. I wouldn't be surprised. Good luck. Bye.